shifted to this decentralized architecture. So they have divided this central node into multiple central node and they call it as decentralized. So each central node or divided central node is catering to some limited number of users. So it has resolved to some issues of scalability and single point of failure to some extent, but still only the intensity of those issues have reduced. Like you see, like this one is a centralized architecture, and this one, if we take a small snapshot of this decentralized architecture, then this is also in itself a centralized architecture. So whatever issues were there in centralized architecture are also there in decentralized architecture. The only thing that has improved is that the intensity of those issues, like if here the intensity was 5x, then here the intensity has reduced to x, but still the issue is still prevailing. And this is the architecture, the distributed architecture which blockchain is following, where there is no central node and every node is connected to each other node in a kind of a mesh network. So every node can interact with every other node in the network. So coming to the limitations of the centralized architecture. So now here, like from this point, we will be talking about centralized and decentralized. Both are centralized only, and sometimes like in different books we see that blockchain is considered as a like decentralized architecture. So actually technically blockchain is a distributed architecture, but when we start calling this as centralized, then we may call blockchain as decentralized also. So there is no point of getting confused whether blockchain is decentralized architecture or blockchain is a distributed architecture. Like it depends like what we are considering centralized to be. So there are various limitations of centralized architecture, like everyone knows. We will not spend much time here. So there is a high dependence on network connectivity because every user is directly connected only to the central server, and if server goes down or the network connectivity goes down, then there is no way for any user to communicate with any other user. For example, if we take example of Uber or Ola, like cab booking applications. So if the server of the cab booking application itself goes down, then there is no way for a driver or for a like rider to communicate with each other. So there is high dependence on network connectivity. Scalability is the major issue. Like all the central servers have certain capacity, they have certain like resources, and they can cater to limited number of users. Like if a server is designed to cater to 10,000 users, and if suddenly we put the load of maybe 20,000 or 50,000, then server will not be able to respond properly. So like only one copy of data is maintained in the single location. Like this is also an issue. Like there is single point of failure. Like entire data is present in a single location, that is the server, may it be centralized or decentralized, still it's on a single location. And if that location gets hacked or that location gets down, then entire data is compromised. So another issue is hardware failure can lead to loss of all data. Like if it is not hacking also, like even if hardware failure happens, although these hardwares are not commodity hardwares like the laptops that we are using, these hardwares are priority hardwares, and there is like low probability that these hardwares will fail, but still ultimately it's a machine, and if hardware failure occurs, then we have to lose entire data and very hard to retrieve back the lost data. So we may say that we may keep copies of data, we may use Hadoop architecture or the concepts of big data, but still it becomes difficult to retrieve the lost data. So there are multiple factors that motivate us to move towards blockchain and distributed ledgers. So one of the major motivation that like gives birth to all other motivations is that there is no central authority. Like whenever we talk about any application, like we talk about Drive, the Uber Ola application of based on blockchain. So there is no central authority. Like in Uber is the central authority. In Ola is the central authority. In Drive, there is no central authority. There is a hand raise, Vinay. Like, is there any question? Can we take questions at the last? Okay, I think it happened by mistake, so I will continue. So it can be used without a central authority. So if central authority is removed, so naturally the cost is reduced. So whatever like commission or whatever amount the central authority or the Uber or Ola application they were deducting, so that cost is reduced. So when cost is reduced, so naturally the speed of transaction will increase, because now we are directly dealing with the sender and receiver. There is no like third party in between, so the speed is increased. And when central authority is removed, the traceability is also enhanced. Like now it is more transparent, it's directly coming from the sender, and there is no third party in between who can change the information or who can make some alterations. And like apart from all these benefits, the smart contracts which were introduced by Ethereum and now Hyperledger Fabric and many other frameworks are there, which are helping us to develop more and more dApps. So smart contracts help us to like create various contracts in between the users of the applications, and due to which we can create even more interesting and more like valuable dApps. So these are all the motivations. So now coming to traditional online transactions. So now how traditionally the online transactions happen. So if some person A wants to send some amount, maybe $10,000 as in this example, to some person B, so there will be a trusted third party. So in this example, the trusted third party will be a bank. So it may be any like international or national bank. So what will the bank do? It will validate the entries, it will safeguard the entries, it will preserve historic records, and it will send the money from person A's account to person B's account. But this is too expensive, like the trusted third party is charging its own fees. It's slow because trusted third party is doing a lot of verification, validations, and it's subject to frauds. What if this trusted third party itself is malicious? So if it, or initially it was not malicious, later it became malicious, so then it is subject to frauds. So this is how the traditional architecture technically looks like. It is a very simple and crude surface level representation, but ultimately all the applications, all the web applications or the mobile applications that we are using today, they use this exact architecture. So there is some application and we give some UI to the user, and user fills in some form and all whatever he wants to search, and he sends a request to the server. So entire code, entire like data, entire logic is present in the server. So server makes all the calculations and it sends some queries to the database. So database like responds to those queries back to the server. Server creates the HTML doc, a JavaScript asset is attached to it, and then the response is sent back to the user. So this is how all the applications currently, all the centralized or decentralized applications, they work in this way. So how the architecture is changed by the use of blockchain. So this is how, like we can see both the diagrams parallelly. There was a huge server and there was a huge database initially. So now after introducing blockchain, the database is completely removed and server is there, server is still existing, but the role of server has reduced a lot. The role is just reading the blockchain data and can be done by the server. Like we have this Etherscan is there. Whatever transactions are happening on Ethereum main network, we can, anyone can just go on and click Etherscan and they can see all the live transactions. So but they cannot initiate any transaction or they cannot do any changes. They can, so it is a completely transparent like database or server. Anyone can go and read anything. Nothing is hidden, nothing is anonymous, but still they cannot change anything. So the role of server is limited only to display HTML and JavaScript to the users, but there is no request going to the server. So how all those requests are happening and how the entire database is functioning. So that is all happening using the Web3 and different if we are using Ethereum or we are using Hyperledger Fabric or we are using private blockchain or public blockchain, it depends. Ultimately, it's all happening on the network. So entire data is getting stored on the network, entire calculation is happening by the network. Then technically there are miners and there are different types of nodes and they are helping to manage the network, but nothing is happening on a single point of failure. Like there is no single server where entire code is present, entire calculations are happening. It's all happening in the network. Therefore, it is difficult to hack. So this is the very surface level like presentation of how a blockchain transaction happens. So if there is a P1 node and there is a P2 node, and P1 node wants to send some message, like now transactions in blockchain are not limited to only like monetary transactions, like some, like most of us have heard like only about Bitcoin transactions of blockchain. So it's not only limited to financial fields, like blockchain applications are there in, or we will be discussing like what all blockchain applications are there in different fields in few more slides. They are in almost all the fields as of now. So like drive is one of the example, like it is there in transportation also. So P1 wants to send some message to P2. So P1 will broadcast that message to the entire network. So in the network, there will be different nodes and they can verify the network. So some basic verification can be done by these nodes. And if majority of the nodes say that yes, the message is like verified, then a basic block is created. So a block can have a lot of data. Some like entries are mandatory, like previous block hash is there to make it a chain. So like you must have discussed in previous discussions like how blockchain chain is connected using previous hash. So we use SHA family algorithms like SHA-256 to create the hash, and now in every block there will be a hash of that block and the hash of previous block, and some index is there and timestamp is there and the blockchain data is there. So then comes the role of miners. So miners mine the block. Mining means like they do in-depth analysis, they like calculate the like there is a mathematical puzzle that is given, like different blockchains have different mathematical puzzles. It's called a consensus algorithm. Like we have heard of proof of work, which is the consensus algorithm being used in Bitcoin. So but different blockchains, like there are thousands of blockchains and there are thousands of consensus algorithms, like proof of stake is another one, proof of burn, proof of elapsed time, and like many other applications are there. So the crux of all these consensus algorithm is you give some task to the miners and miners perform that task, and whoever is able to perform that task first, he is allowed to mine that particular block. He is considered to be as a winner of that particular round, and his block is accepted in the main chain and he gets some mining rewards. So now the block has been attached to the main chain, and then this chain, entire chain is updated on the system of P2, and P2 is able to read the transaction that was like happening by P1 for P2. So now the same concepts like we have in symmetric key in cryptography, encryption, like digital signatures are there. All those are used in blockchain also. So you must have heard us saying like blockchain is more of a philosophy than a technology. So it's not any new technology. Like encryption itself is a technology, and blockchain is not a technology, it's a philosophy. Like we have merged different existing technologies together, and we have, like using blockchain, we have tried to achieve something which was not possible in the centralized architectures. So this distributed architecture and was existing since 1990s. So this distributed architecture is not new. So but this consensus algorithm, so combined use of all these like cryptographic algorithms and these consensus algorithms is helping us to achieve those results. Although in itself blockchain is not any new technology, it is using all the concepts that are existing since like decades. So this is like how the Internet of Things is growing. The market of Internet of Things, it's a $1 trillion market. So like this diagram shows, like from the time you wake up from your bed till the time you like go back to bed, you deal with, like knowingly or unknowingly, we are dealing with so many IoT applications. Like everyone is making everything like automated these days. So this is a trend with all the like startups and all the industrial applications also. Like everything from your workplace to your transportation to your like entertainment field, everything is getting automated, and ultimately they are using either MLAI or IoT. IoT is all there. They are mixing with MLAI sometimes and sometimes not. So IoT is increasing. So but there are various challenges. So this is the slide where the combination of IoT and blockchain comes into picture. So there are so many challenges like to like realize in real world all these IoT applications. There are so many challenges like privacy is one of the challenge, heavy load on the cloud servers, the cost of communication between different like IoT devices, or defective architectures or data manipulation. So there are so many challenges, and because blockchain as a technology or as a philosophy, it helps to cope up with all these challenges of the IoT domain. Therefore, blockchain is highly efficient as an architecture to build various IoT applications. So, but still, blockchain is should not be followed as a code of Bible. So it should not be followed blindly. So this is a very nice like flowchart diagram, which it's asking various questions. Like if you want to develop an application, or you want to write a research paper based on some application, or you have some idea and you want to use blockchain in that idea, so it should not be used as a code of Bible. So there are some questions that like you can just read and answer them in yes or no, and then you will finally reach to a conclusion that do you really need a blockchain in your application or not. And if you actually need a blockchain for your application, then what kind of application it will be. Will it be a permission blockchain, or will it be a like public blockchain? So I will share the slides, and if you are planning to develop some application based on blockchain, then you can just like go through this flowchart and you can come to a conclusion that is blockchain actually required for your particular application or not. So as we discussed, like there are so many like related works in this direction. Like I have marked field, like in almost every field, any domain that you can think of is present, and there are so many publications and real life applications also which are related to blockchain, and they are all published in very like high profile journals. Most of them are IEEE transactions, or like good like conferences of IEEE. So these are different fields like energy, education, like exchange, finance is there, fraud detection, government policies, healthcare, insurance, IoT itself, like so many applications in resource management, and like there are so many applications in transportation, supply chain. So blockchain, like as of now, the research papers are more and real life applications are less, but ultimately like using those research publications, people are trying to develop real life applications also using blockchain for different domains. So now so this was the end to the introduction. So now coming to the like main topic for next 1 hour, like we will be discussing like what are the issues in the existing architecture, or if we call it as traditional architecture or the Bitcoin architecture that blockchain follows. So what are the different issues in this architecture? Like although we have written so many publications and so many research papers, but if we practically try to develop blockchain based applications for these like ideas, we will not be able to actually realize them because of these 4 major issues. There may be many other issues as well, but for this presentation, like I have identified 4 issues. Like this is like the work that I have been doing since last 2-3 years. So at the end of this presentation, I will also be sharing the like latest ideas, like which like we can collaborate together, or you can pursue in like guiding your students in the direction of blockchain. So first major issue is that in the traditional blockchain or in the Bitcoin blockchain, there is no ordering of transaction. Like now I need to explain exactly what do we mean by ordering of transaction. Like for example, like there are so many transactions in banking system. Like there are so many like users who have account in a particular bank, and A, B, C, D, maybe like 4 users. A is sending something to B, B is sending something to D, then D is sending some amount to A, then B is sending some amount back to A, and so many transactions are happening. So like if the order of transaction, order means the timestamp order. So like whenever the transaction was initiated, the order in which the transaction was initiated, the order in which the transaction was processed. So if that order is not same, then like there will be some issue. Like if we talk about banking application, like if A, B, C, D are sending some amount to each other, and the order of like initiating the transaction and order of processing the transaction was different, then also there is not an issue, because like ultimately the account balance of A, B, C, D will remain the same after like the transactions are processed. So whatever may be the order, so the final balance of account will not change. So in the banking transactions, it is not an issue if the order is not maintained, and this is how the Bitcoin blockchain is working. Although the order is not maintained, still like it is not an issue. But if we want to use blockchain in different IoT applications, so all IoT applications are not like banking transactions. So there are some IoT applications, for example, some IoT applications, we will be taking examples also to be more clear, but some IoT applications are there which work on FCFS logic. So like first come first serve logic. So if some IoT application is there and it is working on the logic of first come first serve, and in that case, if the order in which the transaction was issued by a user and the order in which transaction was processed by the blockchain network is different, then it will like deny the rules of first come first serve. Like if someone has initiated the transaction first, then his transaction must be processed first. So this is where the traditional architectures will fail, although someone might try to use the same proof of work and same like the blocks and chain data structure of blockchain, and they may develop a application which is following first come first serve like logic, but in real life it is doomed to fail. So second major issue will and that happens in traditional architecture is it does not support microtransactions. So microtransaction means like we have seen in IoT, like there are so many applications. So some applications which are using very like microtransactions, which means the amount of transaction is very minimal. And if in blockchain like there is some transaction fees and there is some reward to the miner, so if the cumulative amount of transaction fees and reward to the miner exceeds the transaction value itself, then there is no point in developing that kind of application. Okay, so the current architecture of blockchain does not support your microtransactions. And another major issue is like there is no consideration of task criticality, or like some tasks are deadline sensitive, like some tasks have a higher priority even if the transaction is issued from a timestamp point of view, the transaction is issued early, but still its deadline is deadline sensitive, or it is a high priority task. So those things cannot be considered in current architecture of blockchain. And the fourth major issue, like where most of the researchers are heading towards, like those who are working in the like domain of networks, they are moving towards quantum cryptography or quantum resistant crypto systems, or there are different buzzwords which is quantum proof blockchain or quantum resistant blockchain. So like quantum computing and quantum cryptography is like running at a very high speed, and if like quantum computers are like practically possible, then the complete blockchain, the complete existing blockchain is doomed to fail, because it's completely dependent upon like these SHA family algorithms, which are completely dependent upon like majorly the prime number factorization. The major like mathematical model of all the cryptographic algorithms is prime number factorization, and like quantum computing is very fast in breaking like all the algorithms which are dependent upon like prime number factorizations. So SHA 256 also completely depends on prime number, and some algorithms are already there, like Grover's algorithm is there, Shor's algorithm is there, like which have proven to like break the existing systems. But the only issue is the existing hardware is limited, the existing number of qubits is limited. So the day like we are able to have the real hardware on simulations, we have already done those things, but when we have a real hardware, then the complete blockchain ecosystem will fail, and we have to make it quantum resistant before we like the quantum computing field engineers, they get the real hardware. So now moving to from one by one, these issue 1, 2, 3, 4, there are different like use cases or different applications So the like slides have a lot of mathematical stuff also, like actually how these algorithms work and how we are able to solve the problem of ordering of transactions or micro transactions. So I might skip some mathematical stuff because time is limited, and I have to like put more stress on future directions so that we can work together and we can guide more students like more efficiently. So the first example is like ordering of transactions. So like I have taken an example of parking slot allocation. So suppose we want to develop an application for parking slot allocation, and we want to use blockchain in that scenario. So now parking slot allocation clearly works on first come first serve basis. So someone who has reserved a parking slot first, so he is more like eligible or more like liable to get the parking slot first, because it is limited. Parking slots are limited and cars are more. So like who has reserved first, he must get first, and who got late to reserve, like he has to wait till another slot gets empty. So now if we use the traditional architecture here, then in traditional architecture is not maintained. So someone who had like reserved later, he might get the parking slot, and someone who had reserved like previously, so he will not get the parking slot. So this application will not work as expected if we develop, even if we develop this application using blockchain on the traditional blockchain architecture. So we have to fine tune the architecture of blockchain. We will discuss how we can fine tune the architecture. We will not go too in depth in that direction, but this is the like one area where we cannot use directly the existing architecture, or we cannot use the proof of work algorithm here. So another second issue was micro transactions. So this is another like area, another example where someone might think of using blockchain, but still if he uses the traditional architecture, the application will fail. And the domain is mobile networks. So offloading, and like we have applications like mobile data offloading or mobile computation offloading. So there are various low computation devices, and in the network there are high computation devices, and high computation devices can do computation on behalf of like low computation devices, and they can charge some micro transactions. So just because I am using my like I have a very high end device and I don't use it much, so why not like give it on rent? So these are like future research applications. As of now, at least in India, these applications are not there, but these are practically possible. Like if you have a high-end device, you can use the computation of your device to support some low-end devices in your Wi-Fi network, and then you get some monetary benefits. So but these benefits are like very little. The amount is very small. So these are micro transactions. So if we develop such kind of applications using traditional architecture, and the mining fees and the reward will go beyond the actual transaction value, so then we cannot use the traditional architecture of blockchain in such applications as well. So another third, like which is mapping with issue 3, where deadline sensitivity or priority is there. So this is the application of IoD, like Internet of Drones. This is also a futuristic application, like where drones, like till now we have been reached to a like place where drones are used for your last mile delivery, like in the delivery system or in the logistic system, like drones are there for the last mile delivery. But there are proposals like drones can be used. There can be drone charging stations in between on the entire highway, and drones can be used to like make deliveries for a larger distance also. But in that case, we have to take into consideration the criticality, like how critical thing the drone is carrying. It is a drone ambulance, like is it carrying some medicines or some like emergency stuff, or it is just a like Amazon drone, or like it is just carrying some logistics. So we have to think based on criticality or deadline sensitivity or priority, and then we have to make decisions. So if we try to develop an application of this kind using traditional architecture of blockchain, so we will not be able to take care of the concepts of criticality, deadline sensitivity, and priority. So these are the three areas, and the fourth one is the quantum computing. So like we can see some numbers, like if we have a 112-bit crypto system. And using classical computer, like we have like even bigger 128 or 512-bit crypto systems are there. But even if we consider a basic 112-bit ecosystem, then classical computers cannot break it for at least next 30 to 40 years. But on the contrary to it, if we have a like 160-bit, even of 160-bit elliptic curve like ecosystem can easily be broken with a 1000-qubit quantum computer. And we have already realized up to 128-qubit quantum computers, which are there, hardware is existing up to 128. And like I don't think much time will be taken from moving from 128 to 1000, because entire like research is being done at very fast pace, and Google, Amazon, IBM, Cisco, all the big companies, big giants, they are working. Even like recently, like government of India has passed 6,000 crore rupees of research funding for quantum computing. So if anyone is looking for like good funding for the research proposals, we can like write proposals in quantum area, quantum cryptography or quantum computing, and government is ready to give any amount, like if someone is ready to do research in the area of quantum computing. So just a 1000-qubit quantum computer can immediately break 160-bit elliptic curve ecosystem. So it's really a like matter of concern for blockchain, because blockchain totally depends upon all these algorithms which are based on cryptography. So now coming to the solution. So we have discussed like all the issues that are there in the existing architecture. So we must, first of all, we must not blindly like just jump into blockchain. First of all, we have to follow this flowchart, that do we really need blockchain or not. Then we have to think from the point of view of these 4 issues, or majorly the first 3 issues. The fourth one is there for all applications, and we have that is a different research domain. But we have to think from the direction of first 3 issues, like if our application needs like ordering of transaction, if our application needs microtransactions, or if our application needs like prioritizing certain transactions, then we cannot use the traditional consensus algorithms or traditional architecture of blockchain. These examples are like I have given one example, but there can be so many examples in all these different domains. So therefore, so many IoT applications are kept bereft of using decentralized architecture. So that is the work that like I have been doing since last 3-4 years to develop or fine-tune the architecture of blockchain, so that all these applications and many more IoT-based applications can leverage the benefit of distributed computing, distributed architectures, and consensus algorithms of blockchain. So now these are the like different works that have been done. So we have proposed some parking slot allocation algorithm for this application using blockchain, but the algorithm is not traditional, it is advanced algorithm, and same for microtransaction, and same for deadline sensitivity and prioritizing the tasks. So, and for quantum computing, like this is a different domain. There are different tools that we have been using, like PennyLane is like if you want to work in the direction of quantum computing, then PennyLane AI, like PennyLane. So PennyLane AI is one of the like best tool or best simulator or best framework which is there, where you can easily simulate your like ML based, like it's a framework for QML. Like this is the new research area which is coming up, which is quantum machine learning. So we are like it's a hybrid of quantum computing and machine learning. So they are running different machine learning based algorithms on quantum computers, and they are trying to reduce the number of parameters and increase the accuracy or reduce the time, inference time basically. So PennyLane AI is one of the important tool which can be used. Another one is CIRQ. Another one is Qiskit, which is a Python library which is given by IBM. So there are different like simulators which are online available, where you can run your own Python code like whatever code you have written for your machine learning model, be it be a CNN model or it be a deep DNN, like deep neural networks, maybe LSTM or whatever neural networks you are using, and you have written some code in Python, you can, using the Qiskit library, you can just translate it into Qiskit supported or quantum supported code, and you can run your code on a real quantum computer or a simulator of quantum computer, and you can see the difference. You can see like how just by shifting from classical computation where everything is only binary 0 and 1 to a quantum system where there are so many, like unlimited number of states between 0 and 1, that is called as superposition. Like basic difference between classical computer and quantum computer is classical says there are only two states, 0 and 1, binary, which we all know, and but quantum computer says there are not two states, there are unlimited number of states, and there are many states between 0 and 1 also, and whenever a like bit is between 0 and 1, it is called as in superposition, and this is realized using Hadamard gate. So Hadamard gate is the most important gate of quantum computers. So if you want to discuss, I am like very deeply working on quantum computing and quantum cryptography. So if someone wants to like take this direction, then we can have some offline discussions. So now moving ahead. So this is some like a simple graph which is showing like the placement of the proposed DAG chain based algorithm. This is the proof of work algorithm, like the traditional blockchain based architecture, and this is the standard like BFT, like you have heard of Byzantine fault tolerant like algorithms, which are traditional algorithms for finding out in a distributed network to reach to a particular conclusion. Like these BFT algorithms were used traditionally, they are being used today also, but the problem is with BFT algorithms are they can support only maximum to 20 number of nodes. So if number of nodes in a network increases more than 20, then these BFT based algorithm become too complicated and they start taking a lot of time and lot of mathematical calculations and a lot of cost also. Therefore, they are useful only up to 20 number of nodes. So now blockchain, what blockchain did, it increased the number of nodes to thousands. Like you can, like as you know in Bitcoin, like thousands and millions of users are using blockchain, and still like proof of work is supporting them. But the trade-off was that the transaction per second or the throughput of the transaction has reduced a lot. So the time that each block in Bitcoin takes is around 10 minutes. Like whenever you do a transaction, it will take 10 minutes. And if you talk about Paytm or PayPal or any other like Visa or Master, all these banking transactions, they are doing like at least 7 million transactions per second. So there is a huge gap between the number of transactions that a normal centralized banking system can do and what a blockchain based banking system can do. So but our proposed algorithm is present here. So we are able to maintain the number of nodes at par with blockchain, and we are able to like keep, so there is a little difference, but still we have increased the transaction throughput to a good degree, which is comparable to standard BFT protocols. So like there are different attempts like in between also, like these are all different works, like Bitcoin NG is there, Ghost proof of work is there, and inclusive blockchain, hybrid BFT, optimistic BFT. So this is our proposed DAG chain. DAG here stands for directed acyclic graph. So this is a different data structure which we have used. So our blockchain is or like many other people are also using this data structure, the DAG structure. Like if you have heard of like IOTA is there or hash graph is there, like there are different cryptocurrencies which are also, IOTA is working on Tangle data structure and hash graph is working on DAG data structure. So there are different blockchains which are working using different data structure itself. Like some blockchains are introducing new consensus algorithms, like apart from proof of work, they will introduce some proof of elapsed time or proof of stake. But the basic, the core data structure will remain same. Like there will be different blocks and blocks will be connected like a chain, and there will be previous hash and hash, and the data structure remains the same. But in this or many other like algorithms or blockchain architectures like this, the data structure itself is changing, like from chain of blocks to a directed acyclic graph, or chain of blocks to a tangle. So this is the first work. So it has been published in IEEE transactions on vehicular technologies. So its impact factor is 5.3. So I will be moving little fast. This is the motivation, like why we picked this parking slot allocation problem. So different parking lots are there in a vicinity, and some parking lots are utilized heavily because they are like big parking lots, and other parking lots are not being utilized heavily. So this is the data structure which I was talking about. So this is also a blockchain only. So but this is not based on the data structure which was traditionally used in blockchain. So this is a new data structure which is a directed acyclic graph. So what we mean by directed acyclic graph? So it is directed in one direction. So it's not, so a graph means there are multiple nodes and multiple connection in between the graph, but directed graph means it always grows in a single direction and it is acyclic. So you will not find any cycle, like no node will be connected back to the, so like no lines in this graph will appear to make a cycle. So this is a directed acyclic graph, and we are using some internal like algorithms which are called as gossip protocol. So which is also like not used in traditional blockchain architecture. So in traditionally they are using the concept of broadcasting. So in Bitcoin they use the concept of broadcasting. When transaction comes into the network, it is broadcasted to the all the other nodes in the network. But here we are using the gossip protocol. Like everyone knows that gossip works much faster as compared to broadcasting. So broadcasting also does the same thing, like it sends the same information from one node to the entire network. But gossip is like a forest fire. Like once initiated, it like whatever may be the size of the network, it grows very like at a very high speed. So therefore, rather than using standard broadcasting, we have used gossip protocols to like reduce the speed and to increase the, like this is where this transaction throughput is increasing. Like Bitcoin is using broadcasting, and because therefore the transaction throughput is less. But because we have used gossip protocol, so the transactions are reaching the entire network in a very like microseconds or very less amount of time due to gossiping and gossip protocols, and therefore the throughput of the entire like application is increasing. So these are the different algorithms. So this is how our there are different steps how this graph is getting created. So like there is a lot of like mathematical stuff involved in the calculation of these graphs, and like we may not be able to discuss the entire mathematical stuff, like how, like ultimately the goal is same, like whatever goal was there in Bitcoin consensus algorithm is the goal is here also the same, that we want to reach to a consensus. Consensus means the agreement between all the participants of the network, like whatever decision is being taken with the consensus of the entire network. So Bitcoin was reaching that consensus using proof of work algorithm, and here we are reaching that consensus using some mathematical calculations or this hash graph. So another benefit that this hash graph achieves is consensus finality. So if you have heard, blockchain is a probabilistic algorithm, so it never reaches consensus finality. And there are concepts of, if you have heard of, forking and pruning also. Like in blockchain, like some chain develops for some time and then it stops developing, and then another chain develops. And there is a thumb rule in blockchain that longest chain is the most valid chain. So like there are forks developing every now and then, and there is a concept of soft fork and hard fork, and then you have to prune those forks. Pruning means basically you have to cut the extra parts of the chain and you have to maintain the main chain. So therefore blockchain is always probabilistic. That means today you have like attached one block into the chain, but maybe like you are not sure that it is actually a valid block or not, and maybe after few days you might have to prune it or you have to cut it from the chain. So but this algorithm, the DAG chain or hash graph or like directed acyclic graph based algorithm for distributed networks is a uh, algorithm that reaches consensus finality. So whenever some decision happens or some consensus is achieved, so it is final. There is no forking, there is no pruning, and whatever like one block is attached to the chain, then it will remain attached to the chain, and therefore it is more efficient as compared to the traditional blockchain based architecture. So these are like different steps. Maybe 13 steps are there to develop this graph, and once the graph is developed, then finally we reach the consensus for one transaction. So for every transaction we have to develop this directed acyclic graph, but because it is being developed mathematically, so it takes very less time to develop this graph because mathematical equations are already predefined, and it takes very less time to find out the actual values after calculating. So these are the steps which are involved in the main paper of the parking slot allocation. So there are initially different like cars and there are parking lots, and they want to search for a particular parking lot in a like nearest to the like destination where the car wants to reach, and in a very like optimal cost also. So we have considered cost factor also here. So whatever transactions like all the parking requests and they are recorded in the hash graph, in the directed acyclic graph, then they move to the smart contract where like this. So this is the part of blockchain. Then smart contract is same as Ethereum smart contract. So we have not changed anything in smart contract itself. We have used purely the Ethereum architecture, but in blockchain we have made a lot of changes. So after the smart contract is running, so it is assigning like multiple parking lots and multiple prices are there. So each parking lot owner is getting different cars, and we have used algorithm called as dynamic pricing algorithm. So at the end, finally, what happens is each car is given two options. Like before they reach the destination, they are given two options for parking their vehicle. One is the minimum distance option, and one is the minimum cost option. Like minimum distance means minimum distance from the destination. Like if the person wants to reach destination B, like there may be two parking lots which are at a distance of 100 meter and another is at a distance of 300 meter from his destination. So he is given two options, which is minimum distance and minimum cost, and he can choose based on his requirement whichever parking lot he wants to choose. So it is entirely distributed, and the consensus finality means like whatever decision we have reached here, it is final decision. So it should not happen like after reaching the actual destination, he comes to know that the block that was created is pruned and it is no more valid, and now he has to search for another parking lot. So in this application, it has to be final. Whatever consensus has been reached should stay forever. Okay. So now, like as I told, we have used dynamic pricing algorithm also. So these are some like mathematical stuff which is being used for like calculating the dynamic price. Dynamic pricing basically here means the parking price will not remain same throughout. Like as of now in traditional area we see, like if some parking lot has a price of 50 rupees, so it remains same. Like maybe some malls have parking price like on weekends they have 50 rupees, on weekdays they have 30 rupees, but it is standard, it's fixed. So it's not dynamic, like it's not changing based upon the requirement, like how many people are coming. Maybe it's a festival day, or maybe it's like public holiday. So maybe it's a weekday or it's a weekend, it's afternoon or it's evening. So based on so many factors, the price can change, and we have used this dynamic pricing algorithm to change the price dynamically to help both the parking lot owners as well as the drivers. So we have kept a balanced trade-off so that in different situations, different parties are benefited, And overall, we have proven in the graphs that ultimately we have taken care of both the parties. So we might not be able to discuss each and every equation in this dynamic pricing algorithm. I have given a brief summary of dynamic pricing algorithm, why we have used that dynamic pricing algorithm here. Apart from that, we have also used Hungarian cost matrix to finally allocate one parking lot. We have discussed in slide, vehicle parking lots can be allocated. So for that, there we need some algorithm which is capable of doing job assignment. We have n number of tasks and we have n number of people, and we have to assign one task to one person so that all the tasks get completed in a limited amount of time. So that is called as job assignment, and Hungarian is an algorithm which does that work to its level best, because whatever may be the number of users, whatever may be the number of tasks, the Hungarian algorithm is able to assign the job in polynomial time. So other algorithms are also there for job assignment, but as the number of jobs or number of participants increases, so the time increases exponentially. So but because Hungarian does a good job in this, so therefore we have used this Hungarian cost matrix for so now here it is not exactly job assignment. Here we have parking lots, how many parking slots, not slots, there may be 3 parking lots, but there may be 50 parking lots available. So we have to assign one parking lot to a driver, not complete parking. I'm sorry, parking slot we have to assign, not entire parking lot. So the on one side of the matrix we have this is the algorithm. I will show. I think no, matrix is not there. So on x-axis we have the number of drivers, and on y-axis we have available parking slots. So the same thing is being done here. In job assignment, we are assigning one job to one person, and here we are assigning one parking slot to one driver. So therefore this Hungarian cost matrix fits exactly in this problem definition, and therefore we have used this. So this is the algorithm for dynamic pricing. So I will share the slides and you can go through. Otherwise, the paper is also there online on IEEE Explore website, and you can download. So these are the simulation setups. We have taken actual locations of parking lots in New Jersey location, and we have the latitudes, longitudes, how far different parking lots are there, and based on that we have proven that the efficiency after using the proposed algorithm, this was the graph before proposed algorithm, and this is the graph after the proposed algorithm, and we can see that the efficiency or the utilization, resource utilization, what we are calling here, is much more increased for these 3 parking lots. And we have not reduced the resource utilization of the first 2. The first 2 remain the same, and still the last 3 the utilization increases. And someone might ask how this can happen, if these 3 are increasing, then these 2 must reduce. No, but these 3 are increasing based upon the frustrated drivers, those who were searching for different parking slots in a particular location, and because these 2 parking lots were fully occupied and they were not able to find any location, and due to our proposed algorithm they are able to find parking slot, and therefore the resource utilization of these 3 parking lot is increased without reducing the resource utilization of these 2 parking lots. So this is the major achievement of this algorithm. These are other graphs for comparing the price of parking lot, and this is the another interesting graph which one of the reviewers told us to add in the revision. So this is the comparison of if request 1, request 2, request 3, request 4. This is the timeline. So if these 4 requests by these 4 cars happen to come in this order, so the hash graph is allocating the parking like slot in exactly same order, like 1 2 3 4 request, 1 2 3 4 allocation. But what is happening in traditional blockchain is like this blockchain allocation 1, then blockchain allocation 2 3 4, then different, the order of allocation using blockchain is different, so which is causing a like lot of issues in using blockchain in applications which are FCFS based. So this is the summary of parking lot. So another thing that we discussed was our this microtransactions. So this is also a similar kind of stuff using hash graph and fine tuning hash graph little bit and fine tuning smart contracts little bit. So we can skip discussion on this work, and we can directly jump to our like future directions, so that we are able to finish on time. Like this is to some extent similar kind of stuff, but the algorithm which we have used, the hash graph algorithm, has changed a little bit. There are some internal mathematical equation level changes in the algorithm which are helping this hash graph algorithm to introduce microtransactions. Like microtransaction, how we are catering to microtransactions? It is in a way that we are reducing the mining fees to zero. Like initially blockchain was having a mining fees, and what was the mining fees for? So we have to understand it like little thoroughly, like how microtransaction is being catered. So mathematical stuff we can skip, but this is the main part, like how microtransactions are being catered in our proposed algorithm. So what was happening in blockchain? Like in blockchain, like miners were doing a lot of stuff. They were mining, they were validating, they were adding the block to the chain, and they were doing all the management of the chain, and they were using their own computation capability of their supercomputers. They were using their data storage, and therefore they were in return they were getting some mining rewards. So now like the same thing that and that was called as mining fees. Now the same thing that miner was doing in the like normal traditional blockchain is being done using mathematical calculations. So using mathematical calculations, we are creating the graphs, and using the graph we are reaching to the consensus. So there is no need of any specific kind of node in our proposed blockchain. So in traditional blockchain, you must have heard there are three kinds of nodes. One is the normal node, one is the partial node, and one is the mining node. Partial node, full node, and mining node. But here in the proposed, and therefore that is also kind of centralized, because we are differentiating between different kind of nodes. Like in centralized also, what we are doing the same thing now. One node is central node, and another nodes are all the users. So same thing we are doing in traditional blockchain also. We are just using the architecture of mesh, that is fine, but still we are differentiating between three type of nodes. One will be full node, one will be partial node, and one will be mining node. So to some extent that is also centralized. And another reason is like the mining pools. Like if you have heard of, like different miners come together, they make a mining pool, and they have a lot of computation, lot of storage, and most of the time they are only winning the mining part. And that is also reason that Bitcoin blockchain is moving towards centralization again. So but here we are not differentiating between any nodes. Like every node is equal node, every node is same node. There is no specific mining node, there is no specific full node, partial node. There is practically no difference. Everything is happening mathematically using the calculations. We are developing the graph, and using the graph we are reaching the consensus finality. Therefore this mining fees is zero, because mathematical calculations, these servers on which mathematical calculations are happening, and these calculations are not so resource hungry like our proof of work, like the finding the hash continuously for lakhs of times, millions of times, so that you find a kind of hash where 0000 is there in the hash value. That is, these calculations are not that kind of resource hungry. So they can happen in any basic system. So therefore the cost is zero, and therefore fees is zero. and because fees is 0, therefore we can cater to the micro transactions in like these kind of applications. So this is how we have created a architecture of blockchain which is free from any mining fees, and therefore we are able to, because micro transaction means very minimal amount of transaction value, and if there is some mining fees also, then micro transaction is not possible. So we have to bring the mining fees or the cost of mining to 0 to be able to accommodate micro transactions. So therefore, like this architecture helps us to achieve micro transaction, and the example that we have taken is that we have already discussed is of mobile data offloading. So where we need very small amount of transactions between different users which are helping different other low-end devices for data computation, like data offloading or computation offloading. There are two different kinds of offloading. Either you can download the data for someone on behalf of someone, or you can do some computation or some calculations on behalf of someone. So this is the main idea behind this work, and the rest mathematical stuff can be discussed like later. Like if someone is interested, we can have another offline session and we can discuss. So these are the different algorithms which are used, and we have done offloading cost optimization. So here bargaining game theory is used for cost optimization. This is the algorithm for game theory model which is used. Like in previous work we used dynamic pricing, and here we are using game theory or algorithm for bargaining game theory. So then finally we are doing allocation of mobile devices. These are the simulation settings and some performance evaluations. So now the third part was the drone charging, where we were catering to criticality or deadline sensitivity or priority. So we have discussed this application, like if we are using drone for entire delivery process, so then we have to take care of like what kind of drone it is, what is the battery level of the drone, like how much like miles he can travel with a particular amount of battery, when it is very critical for it to get charged, and what amount of money is the drone is ready to pay for getting charged. So that is all the things that are like considered in this application. The data structure is kept same, but the difference here is like in all like previous two works we had only single kind of node in the data structure. Like here we have two kinds of nodes in the data structure, like one are the charging stations and another are the drones. So therefore the complexity of this application is twofold as compared to the complexity of the previous parking one or the mobile data offloading work. So this is the workflow of this work, and these are the like drone scheduling algorithms that we have used to finally, like we have used along with like hash graph, we have used double auctioning model, because here like in previous work there was bargaining model, so we were bargaining between like two parties, but here their auctioning is happening because there are multiple drones and only one charging station. So who will get charged first? So for that we need some kind of auctioning. So in different kinds of blockchain based application we might have to use different mathematical models, different game theoretical models. So some kind of like brainstorming or some kind of discussions are required prior to starting, like directly jumping into like writing a paper or developing an application. So we have to do some initial brainstorming, like what kind of game theory or mathematical, or we may have to develop our own game or our own mathematical model to be able to achieve whatever we want to achieve using that particular application. So these are some kind of numerical analysis. Now fourth one, which we have already discussed in previous slide, the quantum resistant blockchain. So although existing quantum hardware is not there, so this is how a qubit looks like. So in a classical computer there are gates like 0 or 1. If 0 is there we consider it as on, if 1 is there we can if 0 is there we consider it as off. There is no like current passing through that circuit. It's all electrical. Like whenever one is there, connection is established, and whatever data has to flow, it flows. But in quantum, it's called as a block sphere. It's not called as binary circuit. It's called as a block sphere, and we can see there is 1, there is 0, but there are multiple other states in that sphere. And here we call it as bits. There we call it as qubits. And there are so many different states between 0 and 1 also in that sphere. And power increases exponentially in proportion to number of qubits. Yeah. So this is also important point. Like if we have a 4-bit system or a 8-bit system and it can do some particular work, and we want to increase the capability of that system. So in traditional classical computing, things happen linearly. Like if we increase it to 16-bit, then the computation will also increase that much only. But in quantum, it happens exponentially. Like if 4 qubits are able to do some particular kind of task, then 8 qubits will not be able to do only like twice that much. It will be exponential. So therefore also this quantum computing is of a like major concern for all the engineers or all the researchers who are working in the domain of either blockchain or any like computation related application or cryptography. So therefore, so these are some of the statistics which show that how powerful these quantum computers can be, and already proven using simulators, and certain amount of qubits are already there in sort of hardwares, and other qubits are there in sort of simulations. So these are some of the matrices like classical computers and quantum computers. So if we talk about same AES 128, key length is same 128, but bits of security is 128 for classical computer, and quantum computer brings it down to 64. So same is happening with the RSA family also, like RSA 2048. These are different like encryption algorithms, like different families are there. Like SHA is one family which is used majorly in blockchain, and then AES is one family of symmetric encryption, and then public key encryption. RSA is the major family. So here RSA 2048, the bit security is 112. But if same algorithm is running on a quantum computer, then the security level is only 25. So like what do we mean by bit security here? Like how many 2 raised to power like 25 or 2 raised to power 64 number of attempts are only required to break that algorithm. So if like all these algorithms work on, like I told, prime number factorization, and because it working on prime number factorization, so it's a hit and trial kind of stuff. So you have to keep checking different prime numbers, and like if you are able to find out the 2 prime numbers, the product of which is the final output, then you are able to crack the algorithm. So in classical computer, you need 2 raised to power 112, which is a very, very big number attempts to break this RSA 2048 algorithm. But if we use quantum computer, and if we use qubits, which we are like practically I am using penny lane, the only difference is we are using on simulators, and we cannot actually break, but the same simulator is going to very soon be converted into real hardware. So here we need only 2 raised to power 25 attempts to break this RSA 2048 algorithm. So therefore it is a, like we can see from numbers also, it's a point of concern for all these encryption algorithm. Now coming to how like exactly blockchain is suffering due to like exactly what, there are 2 areas in blockchain which will immediately fail as soon as we are able to realize quantum computers. One is hash collision. What is hash collision is like we are totally relying on SHA 256. Like you have seen, like entire blockchain is based on previous hash, new hash, previous hash, new hash. We are every like and entire that mathematical calculation that miners are doing, that is also hash. In hash you have to find 000. Everything is like calculating hashes only. But we assume there that there is no hash collision, like no like hashing is like unique. Like if you give a same input, then you will always get the same output, which there is same output. That is called as hash collision. And in traditional classical systems, hash collision is very rare. But if we start using quantum computers, then every now and then, every like 2-3 blocks, after every 2-3 blocks, we will have to face hash collision. So due to that, the mining procedure will fail. Another area where blockchain will get a lot of issues is accelerate mining in blockchain. Like mining itself is working in Bitcoin is because it takes time to mine. It takes 10 minutes at least to find the hash. But if the computation power increases multiple folds or exponentially using quantum computer, then it will accelerate the mining process itself. And any miner who is having a quantum computer will be able to mine a new block within fraction of seconds. And then the entire game, entire like mathematical puzzle or entire like idea based on which the Bitcoin blockchain is based upon will fail. So therefore, like it's not just a buzzword that everyone is moving to quantum cryptography or quantum computing. It's really a matter of concern for the researchers to move into like quantum domain and to make the existing, at least to make existing blockchain architecture quantum resistant, if not like quantum free. At least if some quantum attacks are there, it can resist itself. Like zero knowledge proof is a very interesting algorithm, ZKP, if someone of you have heard of. So it is used in blockchain, along with blockchain, to make it quantum resistant, not quantum free, but quantum resistant. So like you can study online about ZKP. It is a very interesting algorithm which is used in some latest blockchains to make it quantum free. So these are some of the attempts that people are doing to make blockchain quantum free. And there are some like standard like algorithms which are being proposed, which can be used in blockchain in future rather than SHA-256. So these are some of the alternatives of SHA-256, which is currently being used in blockchain, which is not quantum resistant. And if we use these algorithms, then we can make quantum blockchain resistant. So now just last like 10-12 minutes we will be discussing, like this is till here was the work that I have already done. Some people are still exploring in these domains. There are so many open issues in these areas also, but still I would like to discuss some latest works that I am currently doing and my research team is currently doing. And so one area is NFT, the non-fungible token. Like it is a recent buzzword. Most of people who know about NFT also, they know only the tip of the iceberg. So like they only know that there are some artistic things, or you can create some music clips, or you can create some like video clips, and you can like put them on some OpenSea or NFT marketplace, and some like rare people in the world, they spend millions of dollars to purchase those NFTs. So that is not the only thing that NFTs can do. So you must have heard of, I don't know, there is an application called STEP, STEP capital N. So this is an application which is based on NFTs, which is like they are selling NFT based sneakers or shoes, and they have created a gamification and GameFi and SocialFi like application, which is used to like people are using that application and they are earning while walking. So people are not motivated to walk these days. So this application is motivating people to walk half an hour every day, or do jogging, or do some running. And when they are having those sneakers in their digital sneakers, not physical sneakers, and those digital sneakers are there in this mobile application, they are earning some NFT based tokens. So another ecosystem where like blockchain domain is moving into is chain communication. So we have got so many blockchains and so many different like standalone infrastructures or frameworks, like Ethereum is one, and Solana is one, BSC is one, Polygon is one, and they are, as of now, all the applications, if some application is developed on Ethereum, so it is able to talk to other applications or other users only within Ethereum ecosystem. There is a lack of bridging or lack of different solutions for interchain communication. So if a new chain has to come into existence, so we have to create so many bridges, and like if this graph goes on increasing, and so it will be exponential graph. So after 5, 7, 8, 10 nodes, we have to create so many bridges between like different chains, and it is not a practical and a feasible solution. So this is one area where my research team is working on, which is an interchain communication. And like this is only like maybe 10-20%. Major stuff that I am working on is quantum computing using Penny-Lane, Qiskit, Circ. And in blockchain, exactly blockchain, we are working on interchain communication, NFTs, and this is another kind of work which is already published in IEEE Transaction on Intelligent Transportation System, where we have developed a alternative to Google Maps. Like Google Maps is using our own data to show us the maps. So same thing we have done using blockchain, like a distributed network where people are helping each other and they are incentivizing also. Like when you go on a road, you like take the image of the entire practically what is happening on that road. You like help others to know the map and you get incentivized also. Like Google is, we are helping Google to show maps, but Google is not incentivizing us. So, but here, like since the same strategy, same algorithms are used to make the maps, but we are incentivizing the users who are helping us to develop that map. And it's not centralized, it's decentralized. And few other, some draft ideas are there, like real estate is one of the industry which can completely shift into NFT based architecture. Property sale, like which is area which is full of frauds, and there are so many transactions which are happening on papers only, and same property is being sold to multiple number of people, and so many different things are happening, and we can like shift it, this entire ecosystem on NFTs and smart contracts. And fractional property ownership, like the property has become like so expensive. So even if someone wants to invest, if he has 10 lakh, 15 lakh, 20 lakh, and he wants to invest in real estate, he cannot buy anything good. So there is a concept of fractional property ownership. Like same property is there, might be of 1 crore rupees, but 5 different people can own that property fractionally using NFTs and using blockchain securely. And whatever like price increase happens on that property can be divided amongst all those like fractional owners of that property. So, and then mortgages, like if we take loans, and there are so many frauds in those things also. So those things can also be shifted on NFTs and blockchain. So that's it from my side. If there are any questions, we can take for 10-15 minutes. And after that, we can have the closing ceremony. So any questions?
Dear participants, if you have any queries, please unmute yourself and ask your queries. Sir is waiting for the queries.
Excuse me, sir. Is there any public marketing in blockchain?
Your voice is breaking. I'm not able to hear.
Is there any meaning in public auditing as in cloud security in blockchain, sir?
Any public
Public auditing term.
Public auditing in blockchain?
Yes, sir.
For cloud security, yeah, like in Bitcoin blockchain, it's not there. So authenticity is one major issue in Bitcoin blockchain. Therefore, it is probabilistic.
Sir, I am not able to.
Sir, you are on mute, sir. You are not able to hear your voice.
Okay, sorry. Okay, so I will speak again. So like in Bitcoin blockchain, auditing is not there. So therefore there is a concept of like probability, like it's probabilistic. But in this hash graph or DAG chain based algorithm, it's completely based on mathematical calculations. So and the entire calculations are present online. So there are some auditing firms which are like doing the auditing of these transactions, because all the transactions are available online on the like scanner of these hash graphs, and they can be audited using mathematical calculations. So there is nothing like no manual effort is happening in reaching to a consensus. That is the beauty of hash graph or DAG chain based algorithm. Everything is calculated mathematically, and whatever results these equations are coming up, they are coming up in consensus finality. So therefore there is, first of all, there is no point of like issues in auditing or authenticity, and secondly all the transactions are transparently available online, so anyone can go and check. And there are some auditing organizations which are like trying to audit these transactions. Hope I am able to answer.
Yes, sir. Yes.
Hello?
Yes. Hello.
Hello. Good evening, sir.
Good evening.
Sir, I want to know about the simulation of Bitcoin or any cryptocurrency. How we can perform simulation on cryptocurrency?
Simulation, like there are like two different directions. One is like if you want to develop a distributed application using existing like architecture of blockchain, then you can go to Ethereum. Like Ethereum gives you entire setup, like you don't have to do any coding from scratch. Like if you want, like you can mail me personally, I can share you entire course on Drive, where like within 4 or 5 days you can learn like how to create a distributed application based on blockchain using Ethereum. And if you want to develop, another direction is that if you want to develop your own cryptocurrency itself, or you want to write your own consensus algorithm, a new consensus algorithm, then you have to do scripting, like some like maybe so any algorithm, any language, like you can do it on Python also, and you can like entire stuff that is happening on Bitcoin, you have to code it. So like easy way out is use Ethereum, and there are some like plugins available where you can change the consensus algorithm, and you can change some ways in which Ethereum works. But if you want a lot of flexibility, then you have to like write your own code and change it, or some GitHub links are available where people have created their own Bitcoin blockchain. You can download those codes, run them on your system, and then change their code according to your needs. So these are two directions in which you can start with developing distributed applications or like Bitcoin simulations. MetaMask
Okay,
tool, MetaMask tool
sir,
is also,
now
yeah.
SimBlock and BlockSim simulators are used for this purpose.
Yeah, like these are just for the front end kind of stuff. Like you can just like do some transactions, and you can see the wallet, some money is coming in the wallet, some money is going from the wallet, but you cannot develop applications on those like basic simulators. So to develop application, to write the code, to write the smart contracts, you need some framework like Ethereum or Hyperledger Fabric, or like otherwise there are a lot of front end simulators available, like wallets are available, a lot of wallets are available where you can see without having actual money, you can see how like blockchain transactions are happening. Okay.
Okay, thank you, sir. Can you share the course link or any details about this?
Yeah, sure. Like you can ask from Shanti ma'am my email ID, and like you can just drop me an email. I will share you all the details.
Okay, thank you, sir.
Thank you.
Sir, is there any research scope in public auditing the cloud security while preserving the privacy of? Sir?
Cannot get you. Like, can you speak again?
Is there any research scope in public auditing cloud security, sir, while preserving the privacy?
Yeah, there is a like blockchain itself is like because it's holding like transparency. So therefore privacy is a concern. Like all the transactions are public in blockchain domain. Although they are anonymous, but still they are public. So privacy preservation is a major area of concern in blockchain. So therefore there is a lot of scope in research in that direction also. So although we have not discussed that area in today's presentation, but if you are interested in like public auditing and cloud security kind of stuff, like we can have offline discussions.
Integrate the blockchain in cloud security, sir?
What?
Can we integrate the blockchain technology in cloud security?
Like we have to think in that direction. Like exactly, cloud security is a very big domain. So exactly what we want to do in cloud security, like everything cannot, like we had a graph also, like flowchart in our initial slides. So we have to think like blockchain is not like kind of code of Bible. It cannot do everything. So some parts of cloud security can like be catered using blockchain, but still we have to think exactly what we want to achieve in cloud security, and then we can like come to a conclusion that blockchain can help in that direction or not. Mainly it's into privacy preservation and not like into like cloud security, because it's a distributed the architecture itself is like contradictory. Cloud is centralized, blockchain is distributed. So because the architectures are contradicting, therefore we cannot mix them like so easily. So only some parts can be mixed. Okay, so like we have to think exactly what we want to do.
I request everyone to please kindly switch on your camera so that we can take some screenshots. Sir Vikasa, please kindly you also.
Yes.
Dear participants, kindly switch on your cameras, please. Lokeshwari ma'am, kindly take the screenshots. Okay, Tejasvi ma'am, now you can proceed with.
Yes, ma'am. Thank you, ma'am. Thank you, sir. I would like to take this opportunity to thank you on behalf of the organizing team for the inspiring words. It was obvious that you are extremely knowledgeable in the field of advanced blockchain-based transparent and secure algorithms for Internet of Things and issues related with current blockchain technology. And I can link this knowledge up to a great presenting style. I find that the whole area of your expertise is truly fascinating and would like to ask you to consider a repeat performance on some future dates, sir. Thank you once again, sir.
Thank you. Thank you.
Now we'll be proceeding with the validatory session by Shruti ma'am. Over to you, Shruti ma'am.
Sir Vikasa, please stay with us for some more time, like at least 5 to 10 minutes, sir, for the validation.
Yes, sure, ma'am. I'm here.
Thank you, Tejasvi ma'am. A very good evening to all of you. I, Shruti Kansal, faculty from CSE Department, Vardhaman College of Engineering, take this opportunity to welcome each one of you to the valedictory session of International One-Week Faculty Development Program on Blockchain Technology and its Applications, which is collaboratively organized by the Department of CSE and IT, held from 25th April to 29th April 2023. As we have come to the last leg of this FDP, I hope this workshop is very beneficial to you all. This FDP focused on various aspects of blockchain technology and its applications, covering basic and latest developments happening in this area. The Department of CSE and IT conducted this one-week international FDP to create and disseminate the knowledge of practical aspects in the field of blockchain technology. The objective of this FDP was to introduce the participants to the world of blockchain technology and gave an insight into how and where it can be used. The FDP proved to be an eye-opening session and also aimed at imparting knowledge and skills required to handle different tools and technologies that are useful for developing research applications in the area of blockchain technology. The session was very well handled by renowned professors from reputed institutions and organizations. Before we proceed further, first I would like to invite our magnificent participants to share their views, feedback, and experience about this workshop. Anyone from the participants to share for sharing their views?
Hello, madam. Myself, Dr. Bala from Mysuru, Vardhaman College of Engineering, Mysuru. This 5 days workshop was very, fruitful things. I could not share few things because right now I'm traveling, but right now I'm just traveling to my native. But this the workshop was very interesting. Sorry, Malaysian University professor. So yesterday I also become inducted with that means other state professor also. So all those doubts are rectified. Rectified, madam. So thank you so much.
Thank you, sir. Thank you, sir. Anyone else from the participants? Okay. Thank you all. Now I request Dr. Ravi Shanaghi, sir.
Shruti ma'am, let's wait for some more participants.
Okay.
Participants, please share your feedback.
This is Vijayalakshmi from Tech Multitech Engineering. This 5 days FDP is very, very useful and we learn many things from various professors.
Yes. Thank you.
This is from Vardhaman College and my name is Malik. And it is with great pleasure and immense gratitude I'm before you to express my deepest appreciation for the workshop we have just experienced. This gathering for the exceptional opportunity for personal growth and learning and exchange of ideas. First and foremost, I'm gonna extend my heartfelt thanks to each and every one of you attended this workshop and your presence and enthusiasm and active participants have truly made this event a resounding success. I would like to extend my special thanks and of appreciation to our speakers and experts who generously shared their expertise, insights, and experience with us. Your profound knowledge and ability to engage have made a lasting impact on our minds and hearts. Your passion and dedication to your respective fields have ignited a spark within us, motivating us to reach new heights in our professional and personal life. I would like to acknowledge the organizing committee and staff who worked tirelessly behind the scenes to make this workshop a reality. Your meticulous planning and attention to details and seamlessly execution ensured that every aspect of this event ran smoothly. Last but certainly not least, I would like to thank each and every participant for your eagerness to learn, grow, and share. Your active engagement in the workshop discussions fostered a sense of collaboration that will extend far beyond the duration of this event. Once again, I extend my deepest appreciation to everyone involved in making this workshop memorable and transformative experience. Let us celebrate our achievements, forge new connections, and embark on a journey of continued growth and successful together. Thank you.
Thank you.
Hello, ma'am. Once again, madam. Hello, madam. Once again, madam, please share all the content of the PPT to our, email, madam, so that we can able to deploy the, installation process, everything, please.
Yes, sir, we'll do the needful, sir.
Okay, please.
Any other participants who want to share
Yes, madam.
their views?
Myself, Manish Chavda. I am faculty in Vardhaman College of Engineering in AI/ML department, and I am very much thankful to the Vardhaman College of Engineering, especially the CS department, for organizing this very knowledgeable and accurate up to the date this FDP, and we have learned a lot from this in 5 days. Our learning skill has been increased, and we learn many new things. And I am again thankful for the Shanti Makka madam and organizing team for giving an opportunity to attend this. Thank you, madam.
Thank you. Thank you for sharing your views. Any other participant?
Thank you, ma'am. May I?
Yes, please.
Hello. Yeah, my name is Saman Prasad, and I really thanks first of all entire organizing committee and to all these knowledgeable persons to sharing their exposure and experience in terms of the blockchain and how it is going to be nourished our career as well as our knowledge transfer to the learners to bring them from the lower level to the industry level. And it was a really awesome session. And I really enjoyed in terms of getting as much as knowledge and thought processing, how to take the topics and how to deliver that and how to connect with the audience also. So overall, it's really great to be a part of the FDP. Thanks.
Thank you.
Good evening, ma'am.
Any other?
Myself, Kanti from Computer Science Department.
Yes, Kanti.
Thank you so much for the workshop, ma'am. So glad we were able to gather a lot of information about blockchain. The session was interesting. We got insights of blockchain technology, its architecture, and other fields related to it. I just wanted to let you know that this workshop was extremely helpful for us to grab research opportunities in blockchain domain. I would like to highlight the dynamic of the sessions that was very interesting, and the presentations were really helpful for us to understand the concepts. And I would like to thank all these people for providing us with wonderful tips and material. Looking forward to participate in such workshops again. Thank you.
Thank you. Thank you for sharing your views. Any other participant?
Good evening, everyone. I'm myself Divyashi from Reva University. The FDP was very beneficial now since I was into this blockchain technology. My area of research is also in blockchain technology. So this helped me. This FDP helped me in understanding so many concepts of blockchain. So I would like to express my gratitude to all the organizers. Thank you so much, and I would like to attend so many sessions in further, ma'am. Thank you so much.
Thank you, ma'am. Thank you for sharing.
This is Amanpreet Singh.
Just a minute. So Prashant, a few more participants wants to give the feedback. They were not able to, I think, unmute themselves. So they raised the hands up. Please look into the issue.
Ma'am, this is Amanpreet Singh from Chitkara University. The session was quite informative, and I learned a lot from blockchain technology, and lot. Thank you, ma'am.
Thank you, sir. Yes, any other participant?
Good evening, madam. This is Pawan Kumar from J. Polarity Engineering College. I feel very much glad for attending this kind of FDPs in blockchain. Eminent resource persons was nominated for giving the good content, excellent content on the latest technologies. Thanks for conducting this kind of FDPs. I expect the same for in the future also. We are very much willing to join this kind of FDPs. Thank you, madam.
Thank you, sir.
Shruti ma'am, I think we can proceed.
Yes, ma'am. Thank you for your very valuable views and feedback. Now, I request Dr. Ramesh Karnati, Sir, HOD of CSC Department, to enlighten the participants with his precious words.
Madam, am I audible?
Yes, sir.
Okay. And respected resource persons and the head of the departments and the coordinators, organizing committee, and the participants, students, faculty, a very good evening to all. From the Vardhaman College of Engineering and from the Department of Computer Science, I would like to say thanks to the resource persons for sharing your valuable knowledge on blockchain technology to our participants. Though you are busy with your academic activities and the professional activities, and thank you, sir, for sharing your knowledge on blockchain technology to our participants. And thank you to the participants who participated across the world. That shows your interest on blockchain and its applications. I hope these sessions are motivated you to continuing in understanding and sharing and in contributing your contributions to the field of blockchain and its applications. Definitely, I assume that you are going to contribute your contributions to the blockchain technology. And I would like to say thanks to the coordinators and the organizing committee for arranging this kind wonderful FDP and workshop on blockchain technology and its applications. And I would like to say thanks to my management and principal, sir, for giving this opportunity to conduct a workshop and FDP on blockchain technology and its applications with the help of resource persons and the participants. And thank you to all. Over to you, madam.
Thank you so much, sir, for your kind words. Next, I would like to invite Dr. Munishekha, sir, HOD of IT Department, to address our esteemed participants.
Am I audible, madam?
Yes, sir.
Good evening, all of you. From past 4 days, we had a very great learning experience on blockchain technology and its applications. We learned from fundamentals to some real-time applications like car parking, many applications and its problems and implementation. Several case studies also we learned. This learning experience will help faculty and students to implement many projects and implement many case studies. For this, all the things, I thank all the resource persons for their valuable contributions for faculty and student community. And next, I thank principal sir and management for their support. And finally, I thank and congratulate all the organizers, coordinator, Shanti Makka madam, members who worked for this event making successful. Not only successful, it is a great successful. Many participants participated in this event across, I think, 700. Yes, ma'am. Approximately 700 people are
Yes, sir.
participated.
Yes, sir.
Then one more thing, I request all the faculty members and as well as students, bring this, whatever the knowledge you learn here, bring into the practice. Do some useful projects and take up the case studies so that it will be extended further and it will generate employability opportunities for many. And one more thing I want to share, we, Vardhaman College of Engineering, are willing to establish a blockchain laboratory to extend the blockchain applications and bring this blockchain applications to the student community. So I need all the faculty members' support to make that lab successful. Thank you. Thank you all for organizing this wonderful event. Thank you.
Thank you, sir. Thank you so much for sharing the information. Now, I would like to call upon the coordinator of this FDP, Dr. Shanti Makka ma'am, professor in CSE, to express vote of thanks.
Thank you so much, Shruti ma'am. Am I clearly audible?
Yes, ma'am.
Gratitude is not only the greatest of virtues, but also the parent of all the others. No event can be successful without a provision of vast network of people. With this, I, Dr. Shanti Makka, professor in CSE and FDP coordinator, feel honored and privileged to get an opportunity to propose a vote of thanks on this special day. I would like to thank all the honorable delegates who blessed us with their presence. I, on behalf of the organizing committee, convey deep regards and hearty thanks to our honorable chairman, sir, Dr. Vijayendra Reddy, Sri T. Upendra Reddy, Mechanical Engineer Secretary of our organization. They are ably supported by Sri M. Rajshekar Reddy, Vice Chairman, and Sri E. Prabhakar Reddy, Treasurer. I am also very much thankful to all invited resource persons who have been a great source of knowledge to conduct this workshop. We are grateful for the cooperation and contribution of the speakers who actually agreed to be the part of this program and share the valuable knowledge with the participants. To begin with, Dr. S.P. Goyal, City University from Malaysia, who delivered a session on ABCs of the blockchain technology in the era of IR 4.0. Dr. Kamral Hassan, UKM Malaysia, shared expertise on significance of cybersecurity with blockchain technology in Industry 4.0. Dr. Amreen Singh Yadav from Indian Institute of Information Technology and Management, Gwalior, discussed about blockchain technology and security attacks. Dr. Rajesh Kumar Kaushal from Chitkara University, Punjab, delivered a hands-on session on blockchain technology, its functioning and pathway of using Hyperledger Fabric framework. Dr. Vikas Hasija, who has completed PDF from National University of Singapore, currently working with Kalinga Institute of Industrial Technology, Bhubaneswar, dealt with the issues of existing blockchain architectures, ways to resolve them, and recent research opportunities in blockchain domain. Once again, thank you all for sharing your knowledge with each and every one of us. Today, my words are not enough to express the gratitude to Dr. J.V.R. Ravindra Sir, Principal, Vardhaman College of Engineering. Our heartfelt gratitude to our Principal Sir for being a constant source of motivation and support for conducting such programs time to time. We are fortunate to have such dynamic personality as the head of our institution. I would like to thank our beloved head of the department CSE, Dr. Ramesh Karnati. Without his support and guidance, it would not have been possible to conduct this workshop. I also extend my generous thanks to Dr. Munishekar Valpuri, CSE HOD IT, for the entire support provided during this program. I would like to submit our gratitude to all who were involved in conducting this FDP program directly and indirectly. Last but not the least, we must remark a proficient sense of gratefulness to all our participants for being a part of this program and making it an interactive learning experience. Hope the program was fruitful and beneficial for you all, and we will try to keep coming back with such initiatives in the future too. Thank you very much. Now, participants, the quiz is going to start, and the duration of the quiz will be 30 minutes. And the quiz has 20 questions for the 20 marks. And please do not request for the time extension. I request everyone to participate. And the feedback link will be given by 9 o'clock and it will be open till 9:30. Thank you all. The quiz link is like posted in meeting chat as well as in the WhatsApp groups.
Shanti ma'am, as well as in YouTube stream also.
Once again, ma'am, please.
Ma'am, in YouTube stream also in live chat we have posted the link.
Okay, link. Okay, ma'am. Vinya ma'am, I think we can close. You have posted the link in all platforms, no?
Yes, ma'am, I have posted.
Yes, sir. Prasad,
Prasad sir, can you please give confirm? Ma'am, once I'll get confirmation from Prasad Reddy sir and I'll ask him to close. Thank you.
Okay, ma'am. Yes. Okay, sir. Thank you. We can close it.